All right, ladies and gentlemen, welcome back to Deep Thoughts. Today we're going to do a redo, probably the second or third redo, of the mission to Mars. What does this mean if you're new to Deep Thoughts? Well, we discuss the validity of the claim that anyone's ever made it to Mars. I think you can kind of assume where I'm going to go with this whole thing. But what we do on this show, in case it's your first video, is we go into the standard history of these missions and everything that kind of led up to this. And then we go back and we analyze the claims and the absurdity of 1970s technology, then the giant 20-year gap as the art of computer-generated art got into the mix. And then suddenly when CG is possible, man, we got a whole bunch of missions. And we sell the platform to foreign countries that are basically probably swapping debt for nationalism, right? We're going to use a bunch of reference that I got from ChatGPT 4.0. And for those of you who are like, man, don't listen to them, they lie. It's like, of course they do. And that's why we want their information. It's a great way to pull it all together. But then I went into some advanced conversations, knowing a lot about technology, both from the hardware side and the coding side, to look at the absurdity of the claims, especially those in the 70s. So we're going to have a lot of fun towards the end here. But what's interesting about it is you want to have a lot of these factoids in your mind that I'm about to read to you, I'm about to discuss with you, because if you're like me, you briefly touched on some of this stuff. You really got to go back to get the details of the descriptions. And with the revisionistic history that we have today, it's much more organized today as to what they were doing. Meaning I didn't hear a lot of stuff when I was a kid. Could be the educational system, me being a little kid, but I continued to study this stuff over the years. What you will find if you pay attention to your experiences is that we just simply believed it back then, didn't ask any questions. Maybe super uber nerd groups got into it, asked those questions. But most of us just went, yeah, sure. Viking 1, Viking 2, sure. Yeah, whatever. So we're going to clear up a lot of stuff because I have to wade through the comments and make sure that people feel like I've acknowledged, potential errors I've made in quotes. I will say there's some errors that I've been making for a little while that I clarified. So hopefully this will set the record straight. You need to know that any past episode about Mars will be turned off by me, not by YouTube or anybody, because I want the best of the best at the very forefront. So if you go backwards and try to find that stuff, I'm going to get rid of it. And I have to say, I think there's only one that's left. I got rid of the very first one I did, then redid it, and we're going to wipe that one out with this one because we're going to get way more detailed. And this is going to be the format of anything I'm claiming because the audience is growing and the people that are more interested in the facts are more at the forefront. I'm not saying in my OG group, but the OG group already knows a lot of stuff. And so we're gaining folks that are of all different spectrum between knowing everything that's been officially announced to just kind of having general knowledge like we all did when we were younger. So anyway, let's get started. So the first thing I'm going to start off with are just some factoids about Earth and Mars. Okay. Then we're going to get into the first people that ever claimed to have got an image of Mars way back in the 1600s and just touch on some of the key folks moving forward. Then we're going to talk about all the missions that have ever gone because there are reconnaissance missions to take photographs. And then, of course, there's the handful of missions that achieve supposedly a landing operation on the ground. Some of them are called landers, and that's where you have Viking 1 and 2. And then as of 93, we get rovers introduced into the equation. As well, we're going to study real quickly all of the missions that other countries have apparently attempted and failed, because that's important too. It's interesting when a country on Earth has a discrepancy in capability and a non-discrepancy in capability, and suddenly they can't do things that they initially were really good at, and we'll get into all that stuff. Now, I had been misquoting, I wasn't trying to get it absolutely correct, but I was misquoting the closest distance between Earth and Mars, because I was remembering the kilometers as the actual miles, and so I have to adjust this whole thing. The 54 million kilometers, which I think I've said 60 a couple times, I was just rounding up, which I shouldn't have done, is actually 54.6 million kilometers to Mars from Earth. That translates, for the imperial folks, to 33.9 million miles for the closest distance. And this is orbital distance in here, okay? The other thing I'd been misquoting was that it was just a general thing they would say in astronomy class and physics. They would just say that Mars is approximately a third the size of Earth. So for the official number, it's 53% the diameter of Earth. So Earth, I mean, again, this is all their stories. Don't worry about other theories of things. You can't fight them with any other theory. You have to use their knowledge. Now, Earth is approximately 12.7 thousand kilometers in diameter. That translates to 7.9 thousand miles in diameter. Mars is said to be 6.7 thousand kilometers, which translates to 4.2 thousand miles in diameter. So again, a total of 53% the size. What's good for me is that makes a lot of the other things I've been working on make a lot more sense, that it's slightly larger than a third. Now, what's interesting, before we really get into the missions, I wanted to impress upon you, and I'm going to start working in miles, because it'll be too much effort to keep announcing things in both kilometers, the metric and the imperial system. The distance to Mars from Earth, even based on their slingshot theories and all their orbital theories, is significantly more than that. I'm just going to name off a few, okay? Mariner 4, 1964, traveled 202 million miles. This is their numbers, right? Viking 1, 310 million miles. Pathfinder, 309 million miles. Spirit and Opportunity, roughly 302. It all hovers around 300, except for the Curiosity rover, which supposedly went 348 million miles. So even though you might think in your brain it's only that far away, the elliptical nature of even their algorithms is in the hundreds of millions of miles, which is just a mind-blowing amount of distance, right? Now let's talk about, real quick, which countries have attempted missions to Mars and how successful or how unsuccessful they were in trying to do things. Now this should show you who owns Hollywood, who's most successful, who doesn't own Hollywood, who's most successful, and who is got a gigantic debt with the United States to potentially extort this platform for building up their nationalism. I know I'm jumping off a little early in the conspiratorial side. Just keep all this stuff in mind as you're processing this. The United States has claimed 18 successful missions, 10 failures. The Soviet Union has had 2 successes and 19 failures. The European Space Agency is 1 success, 1 failure, and I think that was in the same mission. India, interesting, 1 successful mission. Japan, 1 failure. And the United Arab Emirates, wild, 1 success. Interesting, right? So when did we start looking at Mars as human beings in any documented fashion? Of course, we know that lore going all the way back to the Greek lore. I mean, they named Mars after the god of war. And of course, you go all the way back into the Egyptology or the pre-Egyptians, and you have references to stars and all kinds of stuff. But the official early observations occurred between 1609 and the 1700s, with Galileo Galilei in 1609 being the first one to observe something up there with a little more meat on the bones, right? And again, I recently had someone in the comments that said that you have never seen planets through a telescope, it's all ice. Really weird statement. I mean, I sat in the backyard of my buddy while we found Mars and a reflector telescope. I went to the Griffith Observatory, which indeed could have had some slide in there. And it was Jupiter, oddly, with that little eye in the lower left, like it's just always featured in magazines. Really strange. Why can't we see it when it's a little bit on the wonky side, right? So I'm skeptical about that one. But there's plenty of like shady tree astronomers that have seen stuff in their optics. Now, galaxies have never remotely seen, nor met anyone who have claimed to have seen it with anything out of their backyard. Christian Huygens, 1659, he observes Mars and starts to notice more features on the surface of Mars. Giovanni Domenico Cassini, get this number, in 1666, he determines the rotation and starts seeing polar caps. William Herschel, 1784, he starts to postulate tilts in the actual orientation of Mars, something I've never actually heard before. Johann Heinrich Müller and Wilhelm Beer from 1830 to 1839. They produced detailed maps with all kinds of features on the surface, which is really interesting because the optics as of the 1960s, there was definitely features, but man, it was not very detailed. Asaph Hall in 1877 discovered that there were 2 moons. Giovanni Schiaparelli, 1877. He started doing very famous illustrations of the canals. And he was the first one to really suggest that because there were canals, there might be a civilization on there. And you fast forward a few decades, Percival Lowell, 1894 to 1916, he really ran with the civilization mechanism. And you have to understand that every researcher that ever discovered Earth's continents, anything out there, they are notorious for lying. They'd say, hey, I'm going to go on a boat and I'm going to go sailing. I'm going to go find something. They go buy a map from someone who's already been there. They take all the money and go to some tropical island, drink Mai Tais the whole time, and then they come back, and they're like, yeah, see this map? We made this all ourselves, and I named this after you. And then we find out that some of those islands don't even exist. And of course, people go crazy on the internet. They've been erasing. No, they never existed. They sold a bag of goods to someone with money. So Mars getting more and more interesting, like paleontology, right? 136 dinosaurs were initially discovered. And then the 2 guys who conducted all the fraud of paleontology get dumbed down to like, I think 32. And then suddenly a bunch of things that they invented by all kinds of techniques of building fake dinosaurs. All of a sudden, all the real dinosaurs look like the fake ones. Just go do your research or watch my video. You'll be very depressed if you really need those things to be real. I'm going to butcher this guy's last name, but it's Eugene Antonadi, 1909. They said he provided accurate drawings and debunked the canal theory, which we now know, I mean, even in their official stories, the canals were all deprecated, which is interesting, right? Once you start catching on to maybe some theories of civilizations, oh no, there's nothing out there. Some Jesuit priest walks out the back door. I don't know exactly how to say this guy's name. It looks like Grote Reber, 1940s. He supposedly started doing spectrograms through observing the atmosphere reflections of it and was trying to postulate that. Pretty brilliant idea. And then it basically says various astronomers from 1950s, 1960s got better and better. Now, what you need to understand is there's a twilight zone, and there's other shows out there, but there's a twilight zone that took the best photograph of Mars and pushed it into the beginning of the frame because there was a mission to Mars. I think it's the one with Roddy McDowell. It's just a stringy, horrible shot of this ball. You can kind of see some indications of the polar caps. But isn't it weird that we've got all of these like disk arrays way out in the desert, and what's the use of them if you can't see Mars, which is like next door, right? Really strange, right? Now, there are missions out there that I was basically inquiring about what missions actually just took pictures of the outer surface of Mars versus the surface of Mars, right? And you need to know that almost every mission that was ever geared towards landing on Mars always has photographs as it's coming down. Some of them were dedicated to reconnaissance of just like orbiting and taking photographs. Essentially, there's about 5 missions up to about 2013 that that Google's Mars app online actually uses to harvest data. Apparently, there's no claim that the last few ones have been integrated into that simulation. Okay? And I'm just going to talk like all this is real up to a point. Then I bring out the scythe, okay? Now, what's interesting about the whole thing with Mars, and we don't mention it that often, but there is a fairly documented mission idea by Wernher von Braun to go to Mars instead of the moon, which I find very difficult to believe given his knowledge about rockets and the fact that the moon, again, is the nearest thing out there. There are some built-in sort of logic gates that let you know that the deception's probably very evident, that all these rovers that are on Mars, not one of them is on the moon. Out of sight, out of mind, right? But there were 2 missions attempted in the year 1960 by Russia, both of which failed. The initial ChatGPT failure explanation was failed to reach Earth orbit, which I think means just basically died off during the launch. So they wait 2 more years. And remember, the 60s was the era where Russia was the first one to put up Sputnik, first astronaut, first 2 astronauts, first woman, first animal, all this good stuff. They were just kicking our butts until all of a sudden the machine kicked in and they said, we're just going to fake it. We're going to fake the moon thing and just wipe these people cold, because we also caught Russia faking a few things. And so they can't say anything, we can't say anything. And of course, if they try to say something, we'll just wipe them out. We'll be like, yeah, of course our enemies are going to say we faked it. It doesn't even matter if a bunch of Russian scientists proved it on a piece of paper. We would prove their stuff is fake, and so they'd lose nationalism credit, and we would lose nationalism credit, right? But the Russian tries 4 more times in 1962. All 4 fail. I think it's fascinating that they even admitted failure. I guess the idea is if you're going to launch a mission to Mars, out of sight, out of mind, right? So either what would you do to prove that you actually got to Mars? Now, the idea that you're going to land a rover on Mars is quite incredible, right? What's fascinating about the whole thing is that they believe in 1972, when the last rocket that the Russians had put together to try to go to the moon blew up on the tarmac, and some catastrophic explosion that I don't believe was ever released as a video recording of it. They had, tremendous boosters. We now know their boosters were 2.5 times stronger than our boosters from the 90s. As a proven fact, there's a whole documentary about it. We bought them from a Siberian warehouse, brought them to America, and changed our whole design to their 1972 boosters. So imagine how much more powerful one of their boosters were from the Rocketdyne ones we used in the Saturn V, and they had a litany of them on the bottom and still said they couldn't escape Earth's gravity. But here's all these Mars missions that supposedly had a problem when we left the Earth's orbit because it's early in the game. We just claim anything we want. So wait a couple more years. Remember that Russia did 2 in 60, 4 in 62. Now America does 2 in 64. First one, Mariner 3. We lost track of it. But they said Mariner 4 flew by and got the very first images of Mars. 1969, we have to wait another 5 years. 2 more missions, Mariner 6 and 7, 75 images from 6. 126 images from 7. And we're going to get into all this technology here. 1971, they wait 2 more years. It's like this weird thing. You got to wait 2 years to go back to Mars, right? So the Russia says, what they call the Mars 2, they successfully crashed a lander into the surface of Mars. Mars 3 successfully lands and transmits for 20 seconds something back to Russia. Again, this technology is going to be really fascinating here. Then Mariner 8 and 9 happened the same exact year from us. 8 failed to leave Earth orbit. 9 successfully orbits Mars. 1973, 4 more missions from the Russians. The Mars 4 through the Mars 7. 4 fails to enter orbit. 5 supposedly orbits for a little while and they lose contact with it after a few days. 6 crashes and they lose contact with it upon landing. And 7 misses Mars altogether. Now, remember what we say about the 2-year waiting period, right? So 73 had 4 missions from Russia. What's 2 plus 1973? 1975. Okay, now we have the Viking 1 and the Viking 2. We're going for broke now. We not only successfully enter orbit in Mars as the United States, but both crafts land. That's all I'm going to say right now because we're going to go into Viking 1 tremendously because just like Bart Sibrel's entire theory, if they were going to make any mistakes going to the moon, Apollo 11 has got to be the one with the most mistakes, which of course he was correct, although boy, they really challenged it with the other missions, right? So the only mission ever attempted during the 80s, and this is a very important thing. I'm going to bring you back to the CG world once we get through this basic list here, is Russia in 1988. They called the Phobo 1 and the Phobo 2, at least that's how we would say it. 1 lost contact on the route to Mars. 2 orbited Mars but failed before deploying its landers. So he had like some crash or something. 1992, we have the Mars Observer, and it screws up trying to enter orbit. Now fast forward to 1996, Russia puts out the Mars 96, aptly titled, failed to reach Earth orbit, which means it crashed right off the bat. And so at the same time, we're putting up their Pathfinder, which is our little tiny rover that they say both achieved orbit and landed. We also put up our Mars Global Surveyor, which successfully enters orbit. And this is where it's bringing back some of the very first images of Mars. What do we say about 2 years? 1998 now. Japan tries and it fails to reach Mars orbit. Then we have the infamous one that we're going to talk about a little bit later. The Mars Climate Orbiter lost during orbit insertion with a bunch of ridiculous excuses as to why that was. Now we're starting to speed up a little bit. 1999, we didn't wait 2 years. We went right in. The Mars Polar Launcher was lost during landing, United States. Deep Space 2, also United States, lost with Mars Polar Lander. 2 more years goes by. 2001, Mars Odyssey successfully orbits. 2006, we get 3 United States ones, all completely successful, of course. The Mars Express, Spirit and Opportunity. 2005, we say about 2 years. 2003, 2005, that's pretty cool, right? A Mars Reconnaissance Orbiter successfully gets into orbit. We are good. We are good. What do we say about 2 years? 2007, the Phoenix successfully lands. Now we got to wait 4 years. Curiosity, and which ours completely lands perfectly, and the Phobos Grunt comes in from Russia, fails to leave Earth orbit. 2 more years. Maven, USA, successful orbit. Mars Orbital Mission, India, successfully orbits. Isn't that fascinating? India doesn't strike me as a country that's got that kind of technology. Wait 3 more years, and the European Space Agency, the EXO Mars Trace Gas Orbiter, one of them goes into orbit, and then this poor guy, I think, lost his unit and it crashed into the ground. 2 more years. InSight goes up, successful lander. And then wait 2 more years, and we've got Hope successfully orbits. I don't even want to say it's like Tianwan 1. Successfully orbits lander and rover. And of course, Perseverance, which lands. Okay, just painting a photograph in your brain of sort of what the overall attempts were. So before we get into the Viking one, we don't want to go too linear in this whole thing. I want you to think about this whole thing, especially from the ability to fake it. All right. So there's all these attempts up until 1975, and then it's like, or 76, excuse me. It's actually 75 at launch, it's 76 it lands. The Viking 1, the Viking 2. I mean, it's the first time we've ever seen the surface of Mars. We saw the surface of Mars, supposedly, right? Now, at the time, we didn't have the internet, so the global population doesn't know what Iceland looks like, doesn't know what Hawaii might look like in certain areas. Hollywood has definitely advanced up a tremendous amount of photo processing. And so taking a photograph of one terrain and then splicing it with razor blades and putting another terrain behind that, maybe splicing that, and then maybe washing the whole thing out with a color. I mean, if you watch certain movies, you'll feel like you're on another planet, but they're actually walking around on a set because it's before CG terrains happen. And you'll sit there and go, man, where the hell are they, right? And then someone will know, well, it's Tanzania, it's some other place, like, Star Wars used a bunch of these sets, right? Well, if you're told it's a movie, you believe it's a place on Earth and it's a movie. But if you remove the humans and you're told it's Mars, well, what defense do you have before the internet? You'd have to travel the entire world. You'd have to show the photographs to people who traveled to figure out where the hell you are. They can just tell you anything. But that game dried up. As of 1976, we didn't even attempt anything really until about 1996, a 20-year gap. Now, I personally have spoke, I should say, at big studios about the evolution of CG. I've talked to universities. So I've done these presentations several times to educate people on how old, anaglyph glasses are versus polarized glasses. You'll find out that most of that technology was invented 50 to 30 years before you ever used it in a movie theater. Like polarized glasses to create 3D was actually invented in the 50s, 1950s, but you really didn't see those movies until the 80s, right? So technology is way ahead sometimes, right? But CG is something I know a lot about, especially the history of computer-generated graphics. And again, no one in the industry says CGI, so if you're ever saying that, you sound like a moron. CG is what people have been saying since the industry was invented. Why say the I? We achieved the very first CG movie in history in 1982, August, called Tron. Okay? I was a big part of that lineage. I grew up as a kid watching that movie. That catalyzed me to want to program on computers. Eventually, every single person who made that movie became either best friends of mine or really good acquaintances. And then you have a series of CG things that happened in the 80s, but you don't actually achieve what Tron did in 82 until about Terminator 2. Where they're combining CG and live action film in the same shot. Last Starfighter is a really good example. You either had a CG shot or you had a human shot in a set. You didn't have them mixed together because it's very costly to do that. But what happened in 1993 after T2 was released, where you have melting people and all kinds of environmental reflection maps coming onto the cop that jumps onto the helicopter, goes through the window and turns into the cop. I mean, wow, right? You have Jurassic Park, right? But what has to do with the NASA part of the whole game? Well, as I mentioned in one of my episodes, very important here, there's a Peter Hyams movie, which was a sequel to a Stanley Kubrick movie called 2010: A Space Odyssey, released in 1984. And Jupiter is a big part of that movie. And what you don't understand, unless you understand the history of this whole thing, is that planet in that movie was done with CG. So a spherical projection of 2D projections that they said they actually got from photographing Mars and then photographing Jupiter with telescopes and straightening it all out so it's a flat plane and then mapping that on there. I don't think that's actually the case. I think they actually created some believable gas, belts and then just wrapped it around it and colored it. They even deformed the shape of Mars to adhere to the story, and I don't want to ruin it for you, but it's all CG. And I stumbled on a recording in JPL where it had the CG artist that actually put this illusion together. Now, this movie comes out in 1984, and National Geographic starts publishing the Voyager pictures of all the gas giants in the solar system very short after that. Interesting. The technology was invented in Hollywood for a movie called 2010: A Space Odyssey. And suddenly, 2 years later, the magic number, we're seeing all kinds of gas giants. Well, that's the same exact ribbon technology wrapped around a spherical object. Just keep that in mind. So we essentially have either photographing sets that were created, which is a lot of work, which they'll do, right? It's worth billions and billions of dollars of money laundering. Or they just go out to Iceland and take a photograph and then splice out the sky and put something else in and wash it all out with some filters, and boom, you got it, right? And digital photo editing was a really interesting thing in the early 80s. Like I've said several times, my father was a professional photographer. And so we'd take photographs of people, weddings, portraits, all this other kind of stuff. They'd have a pimple here and there. And we could actually circle them all on the preprints and send it back to the lab and say, please take this off. And they had software by the mid 80s that was very much like Photoshop, and they could actually heal by, just digitally scraping it off there. But it wasn't for the average consumer, and the software was tremendously expensive and obviously very, very slow. But that stuff existed. But what is the challenge with suddenly being on the surface of Mars in a new manner by which it's not a lander, which is a stationary thing, right? You're going to drive around now. And what's the formula of every single space mission that's out there? They feel like they have to promise the public new discoveries. You have to. You can't just go back and take more pictures. The truth of the matter is, yes, you could. Just stop going to these boring locations which adhere to the terrain of Iceland, right? Where's the 15-mile volcanoes? Where are the pyramids? Where is that big gash down the center? Why haven't you been able to get close to that? And these missions go for years and years. Why don't you just take the little rover, which seems to have infinite power, by the way, and is never swept away by a big sandstorm. I mean, we have storms on the surface of Earth that would wipe these things completely out. A tornado, my God, you see big semis. I just watched a special on tornadoes, and they had this crazy tornado at night. And at first it looked like lit UFOs flying around it, and what that really was someone on the ground that was inside their car, and they got picked up, and what you're seeing is their headlights going around and around at some crazy 1,000 foot up in the air, and they're definitely just going to get slammed in the ground and die, pending an absolute miracle, right? So you're telling me all these rovers have never been caught up in a storm, but it happens all the time. All right. Like I said before, I was at a party in San Diego. I met two of the guys from the Tron team. There's actually a third guy that wouldn't talk to us because he still worked at JPL, and they went to JPL and worked at least 15 years for JPL to create terrain simulation software. Terrain simulation software. I think Steve Jobs bragged on a promo for Toy Story that he had people working for him, which are Pixar people, of course, with PhDs in terrain simulation software. Who's going to award that PhD? You're programming on VAX machines in 1993 when they're 20 years old. Colleges were so far behind. That's why I never finished college for computers, because where the hell could I go where I would learn more than what I already knew? Okay? There's absolute proof that JPL, Jack Parsons Laboratory, renamed later to Jet Propulsion's Laboratory after they found out that Jack was some crazy Satanist with Crawley, right? They were doing some crazy sex church thing, and they found out he was a nut, and they kicked him out, renamed the company. That's really weird, because Jack Parsons was a jet fuel genius, okay? No, by 1996, we were deep inside fantastic CG. We had Silicon Graphics Company providing all these incredible machines with 32 processors in each one of them in the 90s, man. We had Abyss come out. All this crazy. So they were quantum leaps ahead of what they needed to simply create a terrain. All you had to do was translate theories from geologists of theorizing what Mars might be like and simply simulating all this stuff. When I asked the two guys who went and they were already done with their time at JPL. I said, how realistic is your software? And they simply said, as realistic as you have processing power and memory in the machine. And he made an example. He said, quote, you could render every grain of sand if you had the memory. Wow, right? Well, what if you told a military person or somebody who wants to launder $100 billion through an organization over 10 years, well, if you buy me the machine, I can get you that money. Cha-ching, no problem, right? So as soon as Hollywood has this on-ground theory worked out with what should be there, what could be there, and let's design some missions around it, right? Suddenly we start landing there again. And suddenly we can roam around the place. Let's go back to the Viking missions now. Viking 1 takes off on August 20th, 1975, which is one of my grandfather's birthdays, and lands June 19th, 1976. So about 11-month journey. It's only supposed to be operational for 90 days, but it actually works for 6 years. Okay, man, it's not that hostile there, is it? Solar panels, if they had any, well, they just seem to work, man, don't they? You got to find that technology from 1976 on the Viking technology, put it on the roofs of everyone's house. You got to go to those solar panel farms out there in the desert and rebuild it with 1976 technology so that you never have to clean them anymore. Isn't that amazing? I don't know if they had a little radioactive isotope bar. That would be the way they should have done it. So this is a very basic platform, very basic requirement. They're trying to take images. They want to do some soil samples because that was the big thing, right? Little hand goes out and grabs some stuff. They want to watch the weather, of course. Why not, right? And just look at the surface conditions, right? It's a really basic thing. It would be that. If we were to go there, that'd be the way you'd want to rock it. Viking 2 goes up September 9th of 75, lands August 7th, 1976. This one doesn't do as well. This one is supposed to go 90 days. It goes 3 years. So half the amount of years as Viking 1. Now this one's added a couple more things because, you want to vary your mission intake, right? This one's going to look for biological indicators, right? Is there any life in there, any bacteria on there? Now what I heard as a child, they always said they thought they found life immediately after landing on one of these two, and it was deprecated as bacteria that had traveled inside the unit. It's really weird how they would do that. I mean, the amount of specificity you would have to designate in your analysis to say, no, that's a bacillus, bacteria from Earth. That would be pretty phenomenal laboratory being on there. But they also claimed to do seismic readings on the ground, which was interesting because there's a later mission that actually said that they were the first to actually sense seismic movement. So apparently, according to the own notes that ChatGPT gave me, this had a seismic indicator on it, but never measured anything specific. And of course, meteorology stuff. And all those experiments went well, except they didn't seem to read any seismic activity, which is kind of odd because you'd think in 3 years there'd be some seismic activity, right? But still continuing with the mission briefing. Let's go to the actual platform itself of how to get there, because 75 to 76 is, again, it's the same theory of Bart Sibrel. Now, you can explain maybe in your brain making it there in 1994, 1996, all that kind of stuff. You can maybe explain that because a lot of great technology had been invented. Miniaturization had started in electronics. But 75? So I started asking it because this is the big problem that we have today, regardless of how much technology you think you have. Now remember, one of the things we always say on this show is the elliptical orbit to exit Earth's gravitational force is always described as a slingshot. Yet it never actually achieves a slingshot because the amount of fuel to create an ever-increasing orbit to then create the last swing by Earth to then slingshot to Mars is never a part of any platform ever. Even the Saturn V didn't have any fuel designated for a continuously pulsed orbit to increase the orbit in the opposite direction of when it lands on a planet's orbit and then basically condenses down the ring, and that's all just natural. But when you want to invert the slingshot theory and create it from close to orbit, you need a lot of fuel to go around and around, and none of them have it. So that's where it all, leaving orbit of Earth is probably a completely debunked theory. So any theory you have that you've sold your heart on, your pride on, you're just going to have to give it up, or you're going to have to prove beyond the shadow of a doubt without using the definition of the word, without using the word as the definition of the word, right? You can't just take their BS and then regurgitate it back without any explanation. Physics is pretty easy. You're going to have to continue this orbit system with a fuel system, okay? But let's say you get out there, right? Now remember, when you launch a rocket, you're launching through Swiss cheese when it comes to the density of the atmosphere. So wherever you think your astrophysics math is taking you, all that shot, you know, maybe you get way up in the stratosphere where it's so sparse of any particles, then you're starting to get consistent. But where you are at that point is where your calculation has to begin. So you have to completely reassess your trajectory, your speed, and everything. Well, because we have a reverse slingshot theory to get away from Earth, well, you're going to have to control that engine, and you're going to have a tremendous amount of fuel on this vehicle to continue looping to somehow use Earth's gravitational force to then escape. It's not going to be one orbit. Okay, that's simply, you would have to have a tremendous amount of fuel to go way out from Earth, and then you have to push away from Earth because you're going to start getting your ellipsis to tighten up, which means you're going to slam back into Earth's surface. You have to create a big arc in space. So when you come back around, you don't slam back into Earth and you have to take off. None of the drawings you've ever seen signify the drawing that we've been given our whole life, which is one loop around and then poof, you're off. You go to Wikipedia and you look up these orbits, as one of our listeners, probably one of our one-time listeners, challenged me on, and I just went to Wikipedia, grabbed the algorithm and the illustration. It has a crazy mathematician's name in it, and I just basically put it back in the comments. I said, go look that up and tell me how that's achievable without extra fuel. And it was crickets from there on out. It's beautiful how it works, right? But now you're headed in space. And again, you're going to be way off from the first few seconds. So you've got a trajectory in a vacuum. And let's say you manage to get kind of going towards this projection. Remember, we're traveling usually about 300 million miles, up to 350, to then, get yourself to curve up to kiss Mars as it comes by, right? If you were just to take a unit of, say, 60 million miles, being off 1/100th of a degree, if you were headed straight to Mars, would mean you were about 10,500 miles off course by the time you get there. 1/100th of a degree. Like a trigonometry trajectory, ones we use in video games all the time. When you fire a missile and it come out the back of the vehicle and then it's chasing in an arc the moving target that you're going to hit. We do this all the time. They're kind of sort of canned algorithms at this point. But being off 1/100th of a degree, 1,000th of a degree, you're going to miss your target big time. If you calculate the window of opportunity to approach a planet and insert yourself into the orbit, the amount of precision you need is insane. And that's just orbit. Now to say you need to control your speed and your approach such that when you start entering this 1% atmosphere, okay, and you're going to do some mechanism, you have parachutes, retro rockets, balloons for the impact, all this crazy stuff. I guarantee you, you can't be traveling as fast as they say you're traveling half the time, right? How is this vehicle in 1975 making it to Mars? It's pushed out, let's just say, it's being pushed in the right trajectory roughly. Again, with all that chaos down below, with the rocket that's supposedly creating this big ellipsis so it can get out of Earth orbit. And at that point, you're in a vacuum now. There's no more Earth atmosphere for your fire-based rocket system to work, right? When you light up your unit and you start applying pressure to this unit, the only thing you're going to be affecting is the unit itself, not its relative position in space by any means. So if they have cameras supposedly on this unit is what they say, And those cameras are looking out at the stars. This is hilarious for 1975 technology, given that today it'd be extremely difficult to pull that off, okay? The problem is kids know how to program robots today. So when you start telling kids what they can and can't do, and you're claiming to have more technology in 1975 than these Arduino kids, these Raspberry Pi kids have to drive a robot around a room and look at furniture with a massive amount of processing and gigabytes of memory. Here's what they claim. Here's what Wikipedia claims anyway. Well, it's saying that it's looking at star maps in all different directions, which means it has a hell of a lot of cameras on it, right? So I started asking it to explain all, because it was very vague. It was trying to get me to buy these vague descriptions. And I said, look, no, I'm an engineer. Go ahead and give me everything you need to know. I know about the inside of cameras, computer software, the computer hardware. Tell me what you got, man. Well, it claimed that both units had 5 megabytes of this tape memory on the unit. It's telling me that this thing is taking pictures, and it's using this tube technology, which is funny, and it's actually digitizing 800 by 800 resolution images of space in these different directions, and then writing it to tape, and then doing run-line encoding, which I'll explain in a second, which is something with all little kids I invented at 12 years old without knowing it existed. It's just a very standard way to compress the image. So it tries to compress the image down, and then it's retransmitting that at a later time to Earth for even more post-processing to find out where it is in space. Now that would mean, first and foremost, that the vehicle has no spin on any axis. Now X, Y, yaw, pitch, or roll, it has no spin. It's the most stationary thing that's ever been put into space. And I mean stationary to the infinite degree. Any wobble in this vehicle, right? You cannot have those pictures mean what you think it means, okay? Now, being a kid that grew up with a 32K, was it Coco 2 Radio Shack computer, TRSR-80, with a tape drive, I wrote a paint application at 15 with the font, and it did run-line encoding because the only way I could really make the pictures come back okay. What this is this. If you had an image that was all black on the screen, it was 800 by 800, run-line encoding could say, repeat black pixel, really 800 times 800, whatever that number is, right? So B was 16,000. So it's going to go across, and it just keeps plotting within the field, black, 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 black. Now, if you had a star, it might go do black up to this point, and then do some white, and then do some black. And this thing claimed that it had 256 degrees of grayscale. Oh, really? Oh, really? Okay. Anybody who understands computer graphics understands that we had initially 2-bit images, which are black or white. And we had 4-bit and 8-bit and 16 and 32 and 64. And now we're up to like 32 billion colors with 10-bit, right? But yours truly drew video games for a long time, and a product called Deluxe Paint. I used Super Paint. I used a couple other ones, Mac Paint. And it took a long time for us to get to 256 colors, let alone 256 shades of gray. Okay. Because that's a grayscale analysis. You could put the whole computer in grayscale mode, but you're going to have to store all this stuff. All right. Now, it's going to take time to expose this, whatever camera they think they have, and then write it into some digital memory. Okay. So I asked it, I said, well, how long would it take? Because I remember loading programs on tapes. I said, how long would it take to write 800 by 800 pixels to your tape thing? It said basically under, I think, 13 minutes. Okay. Now, I know space is gigantic and stars don't move much because they're really far away. Okay. But imagine that vehicle had any type of like wiggle to it. Some type of wobble, something. Well, then all the stars are going to start wiggling around a little bit. You're going to have some differential calculation of what the hell you're looking at. And you might get what's called blurring. You never know. And you might get repetition in stars because by the time you have written one star on one row, a tiny wobble occurs and that's going to show up in the next row down. The theory is asinine beyond belief. Okay? Processing power on these systems was like damn near zero. But the other idea is when you're way out there, and you're not out there far enough away that the star map's going to change drastically from what it would be on Earth. It's just not going to change that much. It's not like Star Trek where you see all the stars going by really fast. I mean, the idea of how fast you'd be going, you know, it's funny how Star Trek has all the warp designations for the various episodes. To start seeing the stars go by, I mean, you're way beyond the warp capacity of any of those ships, right? So transmitting all this stuff back to Earth is a tremendous effort, wouldn't it be? You have to point some sort of antenna. It's crazy, dude. You have to point this thing back to Earth. Again, on this show, we teach you ethereal sciences because that's what the masters who discovered electricity worshipped. I mean, that made everything that you use today possible. If you took the brains of today and zeroed out all the electronics, they wouldn't be able to invent anything that you have today because they stood on the shoulders. You say, no, you can't use Tesla stuff because he made everything with ether, and you say ether doesn't exist because some morons conducted what the Michelson experiment. They didn't understand what ether was, and of course they defined the wind, used their definition to create a failure, and then they won. That's how this whole thing worked. But what would be a transmission back to Earth? Well, what's that based on? That would be a medium by which you could actually broadcast some electromagnetic, antenna technology back to some source. Really? Okay. Well, what did we do? We said it's 33.9 million miles away at its closest distance to Earth. These things are traveling 300 million miles to get to Mars, so maybe it's not the closest to us when it arrives, right? How is all this transmission occurring? Do any of you remember radio stations back in the day when they would have, like RKO would be able to transmit, over half of the United States? And I think that they found out that was creating maybe some diseases in human beings. And they were like, okay, we can't be doing that. You're going to have the FCC comes in and says, okay, you're going to get so much voltage for your area, but you can't go too much further than that. And then we're going to sell off all the different regions and put it all together. Tremendous amounts of energy just to transmit on the surface of the Earth on land. And now you're in a vacuum, according to NASA, of course, right? And all this equal and opposite reaction is supposed to work, right? To adjust its position in space. And what kind of mathematics do you think would have, how many decimal places would you have to be able to calculate on a slide ruler in order to get an understanding of where you were with these fuzzy ass pictures of stars, right? You would be adjusting and adjusting and adjusting and adjusting. Well, where's all the fuel coming from to adjust, right? I know people love to think these retro rockets worked. And one of you made a great comment I forgot to mention in an episode when the lunar lander is coming back to the service module and you see it spit this little farts of retro rocket, right? And it stops on a dime. You notice that? It's just boom, 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 boom. Well, there's no theory on planet Earth that would actually allow that to happen, even if this stupid Newton's third law would work in a vacuum. Any pressure from any one of those things would create an infinite tussle. That thing, at best, you'd be able to wiggle two of these things and just have the whole thing wiggle up to the port. That's the best you could possibly do. You cannot achieve a zero movement with a little spurt. What would resist it from continuing to turn? But that's what they showed you, and that's what you believed, because before 1969, they spent probably $1 billion on science fiction, television shows, movies, so that whatever they said, rockets work in space. Yeah, sure they do. Come on. And some of you you're getting hip to this. It takes about a year of processing in your brain to literally divorce yourself from all the science fiction you've ever seen. You always hear rockets in space too, right? Well, that's part of their game too, because it's exotic, isn't it? Now, a lot of the definitions you get from ChatGPT are like this. The Viking spacecraft used custom-built hardware designed specifically for handling image data. Okay. What the hell does that mean? Right? What is an image? It's a Cartesian coordinate system of X, Y, and you just have to basically say, what I saw there is what I'm printing here. Same thing with the photograph that's inherent, because you open a shutter and God's light just imprints on the chemical grid on a piece of paper, and it's really quick, and then you put it through a processing regiment for color, for black and white, and you have an image. We all know how, was it CCD chips or the MOS chips that take in images today, how that works. It's still pretty physical today, right? So in this particular case, we have to take ancient technology, write it into a system at 800 by 800, which, by the way, if you think 800 by 800 is sufficient for resolution to find out where you are in space, why don't you get on your 5K computer, your 4K monitor, your 1080p computer, and bring up a picture of space, make it all black and white, make it 256 grayscale black and white, if you know how to do that, right? There's a few free apps that allow you to do that. And put a little star map in, you get it off Google, put it in there, and then save it out to your hard drive. And tell me how big that is. I think the advanced GIF formats will actually allow 256 on that. Now again, most of the computers that I did initial graphics on with Deluxe Paint was either 600 by 400, or I think it might have been 640 by 400. It's a postage stamp on your computer today. And yet this was supposed to deliver so much specific information about where the stars were that you know exactly where you were. Down to being able to, one, get that from this unit in 1975, haul an ass, with no medium by which to transmit back and forth, still is the problem today. Okay, I don't know what you'd have to do to create some sort of transmission tower from Mars to push through, quote unquote, the vacuum of space and get back to Earth. My caution to you is this: once they sell you a platform that actually doesn't exist, then they write on the back of that platform a bunch of other fallacies that simply aren't true. They aren't possibly true. Even if they could fire a rocket straight up and straight out to space and say Mars is really close to us, right? Or it's going to be close to us soon in the 1 year that it takes for it to, get to us, right? So it's pushing and pushing out to Mars. There's no orbit necessary. The boosters are so powerful. But we're going to only guide it with 75 technology. And so the tip right at the very beginning is pretty darn honed right at Mars, or right where it's going to be. This technology cannot make that happen. And what's happening with the nose cone? You'd have to have a camera right out the nose cone, wouldn't you? It'd be pretty widespread. So, because at the very end, when you're trying to insert it into orbit, you're going to have to be taking a picture constantly. It takes a while for it to get back to us. And we're talking about 75 technology. Again, the whole thing with Sobrel and the Apollo 11 problems, right? All the problems are going to first display themselves in 75. It's simply not enough technology to bring this together. You have to think about things in hundreds of millions of miles. You have to start multiplying. Let's just say making it there is perfect, right? So if you did 300 million divided by 300 million, you got a 1-to-1 ratio. You're absolutely perfect. Now start fluctuating one of the two numbers by 1/100 of a percent, 1,000th of a percent, in the hundreds of millions, and just see what your remainder is. What's your mod in that equation? You are getting tons of error right away. The longer the journey, the more infinitesimal the degree you're off, the more you're never going to reach where you are. And the idea that they're just doing it all over and over and over again. Remember, out of sight, out of mind. You can't prove it. You can't prove it. You weren't there. Of course that exists because you didn't see it. And these are these infinitesimal minds that want to win an argument with you, right? Now let's move to 1998, because this is something I've talked about quite a bit. And it's the Mars Climate Orbiter mission. And this was in 1998, and we flew it there, and it crashed into the surface. The number one reason why they say this thing crashed into the surface was because of a unit conversion error between metric and imperial. Okay, so 2 years earlier, we had the Pathfinder land. It drove around, and it's doing great. 2 years later, they want to go back. But what is the requirement if they're faking this whole thing? Because unit conversion error would mean that you have no experience in software development, especially ISO 9000, where everything is checked. Again, I'm going to give you an analogy of the Tomahawk missile testing that happened. It went on for 8 years before this thing flew. And of course, the cover story was that they tried to save money on this particular mission, and look what happened, right? We have something called unit testing in software, and it's been around forever. I mean, we were unit testing the first version of what's now known as TurboTax back in 1989, okay, with people from the Tomahawk missile test, right? So they brought unit testing to us. There's no way that JPL, NASA, and any other international organization would share modules between each other without having ISO 9000 certification, which is the whole bulletproof process of unit testing. It's both a hardware protocol and it's a software protocol. What they're trying to tell you is that they never once tested this system on the ground, which is completely a bold-faced lie. You would never be able to greenlight a mission. It would be like building a Formula One car. Someone builds the chassis, someone builds half the engine, someone builds the other half of the engine, someone builds the transmission, someone builds the combustion part of the engine, someone builds the fuel system. And at no point do you just start the car without any tires on it, right? And some sort of, what they call it, the stress test of the engines, right? The dyno systems, right? You never assembled the thing together and turned it on one time. That's what they're telling you. Because these units didn't talk the right measurements. Simulation would fail in 2 seconds. Impossible, ridiculous cover story. So at that point, you have to start asking yourself, why on earth in 1998 would they spend a bunch of money and crash it into the surface of Mars? Well, there's a simple answer and there's a more complex answer. The simple answer is someone just wanted a bunch of money. We build a piece of crap, we throw it up there. We still get, I think it was just shy of $1 billion or something. But the public price of it was really meager. It was like under half $500 million. Just showing, look guys, we have to spend all this money. When no one was contesting their ridiculous burning of money, right? No one has ever contested NASA's burning of money in any serious way, where they're like on the chopping block and we're going to pull back all this cash. The 90s was the sick decade of startups making tremendous amounts of money. Everyone was rich, thousands and thousands of millionaires, dozens and dozens of billionaires were just forming all over the planet, selling BS online. Most of them services, right? So money laundering straight up is the first possibility. But the second answer is actually a little more interesting. Let's say that, what's NASA do? NASA brings something special to the public when these kind of things occur. If NASA was fishing, okay, they would go out and fish, and they would have some guy, scuba diver, attaching a fish to the hook, and it would be, say, 3 feet wide, 3 feet long, right? And boy, NASA would pull it out, and everyone, yay, boom, 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 and there's a 3-footer. Now, if they're ever going to fish again, NASA wants a 5-footer, because that's just how they work, man. And now the 5-foot fish should have to get attached to it. So when they go to 98, they want something special to take place. They're going to land, they want more inside this thing. But let's just say that they weren't ready. They didn't have surface images of Earth that they could bake inside Photoshop at the time especially that was passable for being the next generation of Mars images. Because this is going to occur later on, right? So you launch the rocket, and you're one of the logistics guys on the top that knows this is all BS. And some big brass person says, are we going to be ready? I mean, this crap we're looking at right now on the conference table is not ready. Are you going to be ready? And they're like, well, sir, we're working really hard. We think we might have it. Okay, we're going to launch this thing because it's the schedule. It's been 2 years. Remember, we have a 2-year thing for Mars. So they launch the rocket anyway, thinking, whatever. We'll get a bunch of black project money. They try, and they can't get the images to pass some specification. So at the last second, they just flip the PR switch and say it crashes into the ground. It's never going there anyway. Probably crash into the ocean somewhere. You're just floating up there in orbit until it just burns up on re-entry, right? So look at what happened in 2003. The Mars Exploration Rover, or the MER-A, launched in 2003, lands in 2004. I was up the night that they streamed on the internet the landing of this thing. It's a really weird experience seeing this. You could tell everybody in the room that believed and everybody in the room that was in on it. And you can just roll back these tapes. Go look at them. You have all the minions who believe. I mean, lie detector test, pass, failed. They believe this is all real. And they just jump out of their skin, man. Oh, my God, we landed. And it landed in this little tiny crater. And all the top brass look at you like, man, they're buying this bullshit, right? I mean, you just look at their faces, man. It's really funny. And they started inviting celebrities. I can't remember which one it was, but I swear to God, like Schwarzenegger was at one of them. They always want to have a little celebrity. It's just the spin, man. It's the gross spin of the whole thing. But now, what was the list of stuff that happened on this particular mission? It was pretty huge. They had a panoramic camera. They had a microscope imager. They had the mini TES, which is thermal emission spectrometer, mass Boyer spectrometer, alpha particle X-ray spectrometer, rock abrasion tool, magnetic array, used to collect magnetic dust from the surface and analyze it, right? HazCam and NavCams, used for navigation and hazard avoidance, right? So this rover can move around quite a bit more, right? Man, did they ever punch it from 96. They needed more time. Maybe they used the 98 thing to pull a couple more bucks into this particular one. They build a piece of crap, launch a rocket. Hell, for all we know, is a spy rocket somewhere. But this is where we get terrain shots, and we get these microscopic shots. Remember these little spheres that suddenly they found, right? And the big cover story was that these little spheres don't occur anywhere on Earth. And they look like a BB. They look like a pea or something, right? How big they actually are, I can't remember exactly how small they were. There's this big thing that it could only happen on Mars in their particular atmosphere. What? Are you kidding me? And of course, they're shaving them in half and showing all this stuff. And at the time, I completely believed every bit of this. Okay, so you have to know this was, I was with you for quite a while, man, if you believed any of this stuff was real. And of course, the outdoor shots, well, it just got better and better and better. But again, Icelandic people and Greenland people have come in and said, that looks like our backyard. And one of the shots is, I'll try to find it, but one of the shots is like verbatim hump in the ground, which this place is covered with NASA people. Up there where it's out of sight, out of mind, they have all these NASA people running around. And what they try to claim is, and I'm sure there's some truth to this, but they're trying to create rovers as they take it to these formidable areas in the world and drive around all their stuff. The only weird thing is the images from those areas, or images of those areas, seem to filter into the early Mars stuff. I think today there would be no need whatsoever to do such a thing. Our software is great, but they had to take, any theory of a surface and turn it into an algorithm such that if you wanted let's say a mountainscape, if you go into Google's Mars, we know we have Google Earth, they have Google Mars as well, and you zoom in, you zoom in. Not every single area of Mars has got really decent pictures claimed to have been created by these reconnaissance satellites. But they've done an absolutely brilliant job with a lot of the brush, how sand might move around in these locations. Now, of course, the other thing is that these things tend to go for a really long time. They go way past their designation, but they're running on solar panels that are visibly covered with dust. If you have a solar panel, you damn well know. If you look at the amount of dust in the photographs of these, it could take a photograph of itself, right? You know that you're a half power on your house. I had a buddy of mine just tell me, he goes, I love it when it rains in California, which is only on average 18 days in Southern California, because it washes off all my panels and I don't have to pay anybody to go up and do it. These solar panel farms, you've seen it. They have these units that scrub them down routinely. And they're just out there in like average desert without sand or anything. I mean, it's just dust. Okay. Well, anytime you have an electromagnetic surface, it's going to literally, the ethereal orbits will grab things and create static electricity and hold particles to the surface. So you got to scrub that crap off. If it's creating or receiving the photoelectric effect and trying to create some type of solar panel electricity, it's going to attract dust. It's just what happens. If you guys could solve that problem, then you're going to make a tremendous amount of money in the solar panel industry, right? But now let's rewind the whole theory of putting any one of these experimental craft on Mars, because it makes no sense. It makes no sense at all. When's the last time man supposedly walked on the moon's surface? 1972. Apollo 17. They drove a big car all over the place. That's really funny. Apparently, we just don't have that battery technology here on Earth. And even though it's supposedly 1/6 gravity, which supposedly means 1/6 the rate of descent, again, they define the wind, they define the loss. And so if you're all bought into their paradigm, then anybody coming in with a rational thought is immediately deprecated out of your mind. The funny thing was Stanley Kubrick, with NASA consultants all over 2001: A Space Odyssey, when Dr. Floyd and team went down into the pit to touch the monolith that they had found on the moon, wow, they walked in normal gravity. Isn't that interesting? They weren't floating all over the place. You had some of the best NASA scientists on that movie because it was a pre-production for what they were going to do without Kubrick, apparently in June of 1968 in an Air Force base in New Mexico. They didn't get gravity wrong in that movie, but suddenly, poof, a year later, everyone's floating all over the place, right? But you would experiment first with the closest celestial object you can find, you can get your hands on, which is most definitely our moon. It's easy peasy, according to the kids that come out of astrophysics who have never actually done it. You realize there's not a single scientist on the ground who claims all this stuff is easy and all the math works. They have never personally seen their math work. How could they? How could they? You have to put them in space, way outside the Earth's atmosphere of any kind, and then let them try to move around and create an absolute 100% stop with little bursts from a rocket on one side of the vehicle. There's all this resistance in space in a vacuum, right? Not even in an ethereal model would that work. But why didn't they send it to the moon? Well, I'm going to take a little guess here. Take a little guess. If we send anything to the moon, with today's optics, if you really wanted to pay attention to a complete launch and get it observed, you could probably watch a tremendous amount of things with not your average backyard telescope of any kind. But remember those arrays that are in the desert where they got thousands and thousands of these hexagonal plates that can look anywhere they want? One of the guys I talked to from NASA that eventually admitted to my face that we didn't go to the moon, as I talked about those arrays, I said, look, you mean to tell me you can't wait for a full moon and just point it all at the moon and start seeing massive details on the surface of the moon? He started laughing his ass off, and that's when he said, yeah, we didn't go to the moon. This guy is top clearance dude. Could not tell a single soul, not even his wife, what he did. My friend knew him for 10 years, right? We would go back to the moon. We'd not only go back to the moon, but we would find a place, safe place on the Sea of Tranquility to put this thing down, unpack the whole thing, and drive straight to one of our landing sites. And based on the number of years that this stuff works, talk about great solar panel exposure, man. When the sun's on that bad boy, it's going to get tremendous amounts of electricity, right? And it could drive to pretty much most of the landing sites we've ever claimed to be on. And hey, we'll navigate around any of the bad craters or whatever that's out there. And if nothing else, we'll come back with one of the best portfolios of moonshots we've ever had. But no. The only people who've done it is China, really. And they had dirt. They had brown dirt all over the moon. That makes complete sense, doesn't it? Because when you look up, you see brown registries in your eye, right? Especially these guys with these massive reflector telescopes in their backyards looking for UFOs and stuff. I mean, some of the shots of the moon from amateurs are absolutely phenomenal. If any part of the moon was brown, it would come into the optic and it would register as brown. Brown doesn't become white just simply because it travels through a vacuum of space. It hits the atmosphere of Earth at night. No way. You would want to prove out this platform. My analogy to you is this. If you and I create a brand new car that runs on water or something, we take Stan Meyer's water fracturing engine and we build a brand new car. And we also have a couple other geniuses on our hands to redo suspensions and stuff because we got some ideas for everything to be better. Are we going to tell the public that on our maiden voyage, we're going to drive from LA to New York? Probably not. Probably not. What are we going to do very first day? We're going to take it to a parking lot, a college parking lot, a big department store parking lot on a day like Labor Day where nobody's open, and we're going to drive that thing all over the place. Maybe we go to the Salt Flats of Utah, we drive it all around there, get some permission, have some fun, a little bit of terrain action going on. Then maybe we take it to a slightly more formidable terrain. We're not going to claim that we can put that thing on a national highway and get across the United States. Be dangerous for us, be dangerous for everybody else. But that's exactly what they do. And the number one reason why, I guarantee you there's a protocol within NASA that's out of sight, out of mind. That is the protocol basis of all these hoaxes, right? Rockets take off and immediately just go over the ocean. They're just out of your sight. Well, what do you have to resolve at that point? You create a beautiful brochure of everything that's going to occur. And today, it is amazing. The amount of claims that they have done certain things. And again, the ISS is going to be retired here real soon because it's starting to become a huge liability. Makes no sense. It's just getting started, man. If I look at my ISS episode, it's just getting started up there. Yeah, but it's too much of a hot target. It's causing problems. So let's get it down out of the air, and we'll just make money different ways. More out of sight, out of mind claims. But why would China be one of the countries? Why would India be one of the countries? Why would Israel be one of the countries to go up there? Why would the Russians just say they went to the backside of the moon? Or China supposedly went to the backside of the moon? My God. Why do they call it the dark side of the moon? Why do they call it that? And what is one of the attributes of the dark side of the moon? It's very, very rocky, right? Plus, we don't have a lot of reconnaissance photographs of where the hell would you land on the backside. The idea that you could do it is insane. It's just insane. Somebody asked me once, why is the backside of the moon more rocky and the one that faces us has got sea of tranquility and smoothness? Well, I'll point you towards Neil Adams, and a lot of his videos have been taken off the internet. He has a channel up there still, but a lot of his moon episodes have been, they're really hard to find or they're embedded in his other films. Now, Neil passed away. Neil was a National Lampoon comedy magazine artist. So he was really capable. That just happened to be his talent. He didn't write the comedy himself, so he was just an artist. But he was also a very observant man, and he was a very scientific man when he was younger. And so he took a lot of courses in a lot of things, and they used to teach expanding Earth theory up until about 65, until Pangea drift comes in. And for anybody still trying to assert that they have proof that these continents just go willy-nilly, and the oceans were always there. I mean, for me, it's just defies all logic. You do not have a logical mind if you want to say the oceans were there when the Earth formed. Okay. All the continents fit together on all sides. They do. And you look at the bottom of the ocean, you can see the expansion on the bottom of the ocean. Grooves that show you how things came together. Now, some stuff has shifted around a little bit. Very little of the Earth is sunk underneath the newly created water that we have as an ocean. But the moon does not escape this technique. Now, again, the official definition of gravity is a bunch of hoopy. The two atoms share information between each other and thus create some sort of attraction. That is known in Wikipedia, known in most science books, to be a phenomenon. The gravity phenomenon, the phenomenon of gravity. Phenomenon and science are two completely different paradigms of thinking. That is basically like, well, then we just let it all work itself out, right? You don't really know how it works. Ethereal scientists, that understand that we're in a pressure system, We're an enclosed pressure system. What's the enclosure? Well, all I can say is, if you think about the fractal of a bubble and the fact there's probably a bottom and a top, it's basically the same thing that a bubble is, and the same thing a planet is, and the same thing as a star is. You've got an injection point and an exit point, and they're making plenty of those other enclosures outside this universe. So there's universes all over the place. In fact, normal physicists and normal cosmologists theorize that like crazy. They just don't explain it. Gravity is nothing more than a pressure system. So let's just take traditional gravity. It'll work fine in your brain, but it's actually because of a vacuum between the two of them. I should say a lesser pressure between the two of them. The Earth is pulling on the moon, and the moon is pulling on the Earth. So if you have an expansion algorithm, Earth gets to expand almost by itself. The moon's doing this, wobbly loop, which is weird because it always seems to eclipse the sun perfectly in a solar eclipse. That's weird. Random rock, 236,000 miles away, eclipses the sun that's 93 million miles away. You don't think that's weird? So the side of the moon that's closest to Earth is where the expansion's occurring. It's actually constantly refining its surface and expanding out. Now, when you take the Sea of Tranquility, this is which Neil Adams proves to you with just some software, they basically shrink the Sea of Tranquility, and you'll have two halves of a crater on both sides of the edge of the Sea of Tranquility. They come back together and go ting, and they're perfect. It's hard to deny that. That is something we can see. He also supposedly has pictures of Europa produced by NASA by flying by. I think NASA picked up on this theory and said everything that we simulate from now on has got to adhere to some sort of expansion technology. But the moon's just right there. You can just look at it. So the backside is its last eruption points of its surface, right? Not craters, but it's all volcanic eruptions, which is why sometimes craters on the moon start to have this phosphorus nipple in the center, because it used to be a volcano and it's simply still active every once in a while when the surface starts to churn underneath. When the plasma core starts to rotate underneath, you start getting more stuff. We have this happen on Earth all the time, right? We have craters on Earth. It used to be volcanoes, and sometimes they have a little nipple in the center, and every once in a while they get active, right? Now, if it still has the tower up to the center of a volcano, you call it a volcano. But the second that thing erodes down over time and is inactive for a long time, they try to tell you it was an object from space that hit the ground. Go look at the crater in Arizona and go look at Diamond Head in Hawaii. They wouldn't dare lie to you about the crater in Hawaii because it's well known that the Big Island's a big giant volcano, and all these little islands came out of the volcano spout that's in a single place on the crust of the Earth. And as this thing expands, it's just creating more and more islands, which is why the islands get smaller and smaller because they're eroded away, right? But the one in Arizona, it's in the center of our continent known as North America. So it doesn't go away, but it just keeps eroding and eroding and eroding. So I think landing on the backside of the moon is probably not something that would be possible besides crashing something into it, right? But let's look at Mars again for a split second and think about, where are they landing all the time on Mars? How come all of the pictures we get from Mars, except the little Bigfoot rocks and I think these little hints that these guys are putting into the system, and we got rocks that look like all kinds of like man-made objects. I think it's all a joke. They find a model, they mark it as an iron rock, which means that the software will ingest that shape and scattered around, and they can probably just fit one in there and just kind of, watch this. We'll see if they find Bigfoot on here, right? It's just a joke, right? Pluto actually had Pluto's face on it. I mean, come on. And we found that CG guys in Hollywood have a technique to create planet surfaces. They'll take photographs of all kinds of stuff, from rust patterns to non-surface things, and then they project it onto a sphere, and then they change the color scheme to be believable terrain, and people buy it all the time. It's a joke in the CG industry for anybody working on space programs, right? Space-based content, right? But aren't there pyramids on Mars? With their reconnaissance stuff from the Viking missions, right? Aren't there pyramids and a face and all that? Of course, they try to deprecate the face and whatever. If it's there, if there's a 5-point pyramid, 4-point pyramid, why not park the unit somewhere near that place, there's plenty of smooth terrain by those locations. Plenty of smooth terrain. Hey, NASA never fails, right? Remember, guys, it's so easy to get to these locations now. And if these things are going to run for 10, 12 years, I think our last one that's still running landed in 2012 and is still going to this day, so it's 12 years old. You mean in 12 years? 12 years you couldn't drive from wherever the hell you landed over to the pyramids? Especially if you planned it? Why wouldn't NASA want to, remember how they like to up the game, right? You want to give us money because we're going to give you cool stuff, man, right? Why wouldn't they want to drive over there? Well, because they'd have to explain it in some geographical way. Because they don't want to say it's anything intelligent, of course. And who knows if they are, right? There are algorithms of the world that look very intelligent. Maybe they're intelligent at a God level, but they're not necessarily intelligent on the mathematical level once you study the chemistry of what you're looking at, right? But why not drive over? Why not get yourself close to something interesting? And that huge Grand Canyon down the center, yeah, you don't want to try to land in that thing, but you could get 1,000 miles away. Remember, the whole thing is what, 4,200 miles across the whole planet? So you can get within 1,000 miles, and over 12 years, you're trying to tell me you can't drive the extra 1,000 miles down to this edge and just take a look off the edge? Wouldn't that be the most fabulous image in the world? We don't fail anymore. We want to go to Mars? Yeah, no problem. Hop in. Let's go. The only way this money laundering machine's ever going to be turned off is if people finally say, okay, enough pictures of Mars already. We don't care. You're never going to be there, right? Your little helicopter that flew in 1% atmosphere. What's funny about ChatGPT about the helicopter, and I mentioned this in a previous episode, but since we're talking about Mars, it tried to tell me that helicopter blades are special and that they only had to move 10 times faster than an Earth helicopter to achieve flight in a 1% atmosphere. Seems strange, huh? Seems strange that 10 times is 1/10 of what you'd think it would take. So let's say it has to have 3,000 RPM. So you would think it would have to do that times 100. So 300,000 RPM. Nope, it says if it's 3,000 RPM on Earth, it only has to go 30,000 RPM. Wow, that's pretty amazing. What kind of special engine did you make that could move 30,000 RPM? That was their little Chotsky to get a little bit more funding, right? Look what we done, guys. We flew a drone, basically, on Mars. What's next, man? This entire space program and all of the underlying deception that makes you believe this kind of stuff, it's so three-dimensional. You have to understand that you were shown models in space before we had CG. That it took a long time for CG to catch up with trying to create fire that would pass for the human mind. They would still take models and blow fire out the back, like all the explosions that happened in space and ILM back in the 70s were always models that were being blown up and then slowed down. And then, of course, the remaster of Star Wars, you start to get the rings and it's all CG and you can tell. So that's to train your brain to believe whatever they have in the next agenda, okay? Don't get that mixed up in your brain. Then, of course, you have the formality of this fake science. You have people like Neil deGrasse Tyson run around and regurgitate stuff, and they get a little more scientific, put a little more heat on it, right? Then you go to university. Well, it's not like the math that they're teaching you is incorrect. It's just the devil in the details is always subtracted. How many times have you had anybody remind you, I would say 0, but then when a rocket is achieving this 11 miles per second stuff to escape Earth's, lower atmosphere, that the atmosphere density is not an issue. Like they're going so fast, they don't even have to pay attention to air pockets and all kinds of other thermals that are going on. You never hear about that. I've never heard about that. But you can ask ChatGPT that kind of stuff and it'll say, oh yeah, you're totally right. I would never volunteer that information to you, but yeah, you're right. No, by the way, it doesn't matter because we have a atmosphere, we have custom hardware that makes that possible, right? If you go on NASA's website and start digging through things, if you watch all the interviews from the NASA scientists, you're never really listening to the really deep scientists. And when the scientists do speak, they're basically dumbing it down for you like you can't understand anything. Well, who knows? Maybe a housewife down the street totally can understand everything that you're saying, but you won't say anything specific because then you get put on the hook for your claims. But if you go to Sbrel.com, SBREL.com, he's got all kinds of interviews where he dissects that they've actually admitted that they can't get through the Van Allen belts, that we've never been to the moon. But you have to see between the lines, right? One thing implies another thing, and therefore a lot of things are impossible. And once you can't get, certain things to occur, a whole bunch of other claims immediately get, divorced and get deprecated. It can't be true. But you're going to have to be astute to see it. But is the public astute? Hell no. They're reposting all these CG images of the surface of Jupiter. So anyway, I hope you dug it. It'll probably take me a million years to edit this thing. I'm going to try to do some decent graphics for you guys. I didn't cover all the details of all the missions because I think it would start getting really, really boring really, really fast. Just know that ChatGPT is a great resource if you want to hear the official story. You can just simply ask it questions like, give me a list of all the missions that landed on Mars, and it will give you all the dates. And if you want specifics, you just go, tell me everything that what the objective was, what was successful, what wasn't successful, and it'll tell you. So if you want to get a nice group of notes together so that you can start picking things apart, realize when you start to smell BS, what you want to do with ChatGPT is start asking questions as if you're believing it, as if you're some high school student with a report due to your teacher. Tell it that kind of thing, and it'll start being less defensive about its answers. It's a key thing. If you start going in and saying, well, this is all BS, you're a liar, it goes into defense mode, and it will start abbreviating everything that you're saying. But just play along with it. Every once in a while, say, that's very impressive. Wow, what about this? And it just starts regurgitating all this stuff it's been told. So if you like this kind of content, definitely get over to deepthoughtsradio.com. Make sure and check out our top picks over there because for all the ones that have been very, very successful or ones that I'm personally proud of, know that a lot of those episodes have lots of images in them, even if they start off with me, potentially in black and white from the past episodes, but you'll get a lot of great stuff. A lot of great details that you just simply don't get from television shows that are trying to spin things one way or the other. And I try to go back beyond, the basic history of any explanation of anything. Know that we are also on podcasts. So if you want to get this inside your car, you could go back and watch the video later. We have a brand new store up there for all the shirts. I had an error with the inventory where when I migrated all the shirts over from the production company to Etsy, I put all the inventories at 0. So a lot of you tried to buy shirts and they're all 0. So it said it couldn't process it. So also know most of the shirts, most everything up there comes in lots of colors. And I make sure it contrasts great. This is the Deep Thoughts Radio alumni shirt. For those that are folks that have been around for 2015, this is really a Chotsky for you because you've been there since day one. I super appreciate you guys. For those of you who contribute on PayPal and Patreon, thank you so much. We're putting a lot more content on Patreon. I opened up the community chat section in Patreon so we can just chat all day long. Just put anything in there and I'll get to you. But anyway, thanks for joining. Take care of yourself and someone else, and I'll see you in the next Deep Thoughts. Over and out.